There's two tests that we do to determine the plastic and the liquid limit. We will start with the plastic limit. The plastic limit is the state of moisture in a soil that separates plastic behavior from solid behavior. So the soil will start behaving as a plastic material. And it's simply a water content. But it's a water content that the soil behaves in such a way that it can be rolled in a surface like this to form a thread. It's very wet. You will find out that the thread can easily be longer than an inch. If the soil is too dry, it will crumble before it reaches the 1 inch in length. In this case, we're slightly on the wet side, so that we're able to actually achieve a length exceeding the inch. And the diameter of this thread is 1/8 of an inch, or approximately 3 millimeters in diameter. So if the material is too wet, like I said, we manipulate it to dry it a little more, or mix it with drier material. If the material is too dry, we will be mixing it with water to bring it to the right consistency. Once we achieve the right consistency, the procedure is just determining that moisture content. And for that purpose, we use the water content determination equipment. It's a scale capable of reading to the 1/100th of a gram. We tare it to 0, and we weigh the dish, recording that weight. Okay, so that would be the weight of the dish or cup. And to that, we will add the material that we're interested in determining the water content. So when we add it, get a representative sample. This would be the wet soil plus dish, having a weight that is recorded. The next step, normally you may have enough sample to do a couple of these determinations so that you can average them, and this goes into the oven. So again, we bring the material which has been dried overnight, and this time the weight that is being recorded is the weight of the dish plus the dried soil. These numbers get recorded and go into calculation spreadsheet that allow us to measure the moisture content. The plastic limit then is the average water content in the condition where we were able to roll the material to a 1/8 of an inch thread for a length of 1 inch without crumbling. Now we're going to proceed with the liquid limit, which is the state of water content that separates liquid from plastic behavior. So to make the soil behave as a liquid, we need to mix it up with a lot of water. We take the material, like we were working before, and we add water to it. And this process is going to take a little bit of time because you want to mix it. And it's very important that it's uniform, that you don't have dry chunks with moist material surrounding it. So it will take you a little time to reach that consistency. Characteristics of the equipment. It's basically a brass cap where we're going to place the material here, and then we're going to cut a groove, and then we're going to drop this at a rate of 2 revolutions per second, and we're going to count the number of revolutions that it takes for that gap to close. Now when we're doing that, if you notice what happens here, the cap lifts, and the amount that is lifted is standardized. It should be 1 centimeter. And to calibrate the cap, you can ensure that this is set up to the right standard, which is 1 centimeter. If needed, that can be adjusted. Okay, so this adjustment screw the idea here is to spread the material onto the cap. Trying not to leave any air pockets inside it. Holding the cap. It's not bad. You got that one? So we have cut a groove, and we can see through the chin on the metal. The idea here is we're going to zero the counter, and we're going to start counting the number of revolutions that it takes for that gap to close for a distance of ½ an inch. So the procedure is to turn it 2 revolutions per second approximately, steady, and the counter is going to take care of the numbers. So here we go. You're starting to see the gap closing right there. We have closed the gap by about ½ an inch, and that's the distance I'm talking about, where the bottom of that groove has closed. So this will be exactly 10 counts for that moisture content. We have prepared a set of samples at different water contents, so if the material was in a drier stage and we did the same procedure, instead of taking 10 counts, we have taken more. The goal is to identify the water content for which it takes exactly 25 counts to close a gap by ½ an inch. Now, because it's not possible to be exactly at 25, we're going to use this number at 10, then we're going to use drier material to get somewhere maybe close to 20, another point about 25, and typically you will determine that from the intersection with the line of 25. We're going to show that in a spreadsheet, but you need normally 3 points that bracket, a couple of them bracket in the 25 point.